All right, y'all. So Module 1 review. All right, so my first problem, and I'll pull up the chat so y'all can answer also. First one, they want me to graph 8y plus 4x equals a negative 16. All righty. On number one, in MathLab, you're going to use the 2-point line tool, which means you need to find at least 2 points for this so you can plot them in MathLab. So on number one, you want to solve it for y first. So I'm going to bring this down. And then we're going to solve that for y. So I'm going to start out by subtracting 4x from both sides. So y'all, that brings down that 8y. The 4x, negative 4x cancel on my left side. Now on the right side, negative 16, negative 4x, not like terms. So I'm going to put them in order with my x first, my negative 4x, and then my minus 16. All right, now to finish solving that, to get that to be a 1y, we'll divide everybody by 8. All right, y'all, so 8 divided by 8 gives me 1y. Well, I can't divide negative 4 by 8, but we can reduce that fraction. So that negative 4/8, if you divide top and bottom by 4, you can reduce that to a negative 1/2 x, and then minus 16 divided by 8 will give me 2. All right, so on this one, I would set up a little x and y table. And I need at least 2 points to use that 2-point line tool. So y'all, I'm going to pick 0. And then since I got a fraction here, I'm going to use 2 for my second number. All right, y'all, so let me plug in and get my values for my y. So I'll start out by using 0 for x. So that'll be negative 1/2 times 0 minus 2. Negative 1/2 times 0 gives me 0 minus 2, which is a negative 2. Now I'm going to put a 2 in for the x. So y equals negative 1/2 times 2 minus 2. So for this one, those 2's will cancel, making a 1. So I just divided them out and made that a 1. So now on top, I got negative 1 times that 1, which is negative 1, minus this 2. And negative 1 minus 2, give me a negative 3. So for my graph, so y'all, I'm just going to go out about 5 since my numbers were fairly small. Alrighty, so like I said, MathLab, you're using a 2-point line tool, and you got to plot at least 2 points for that one. So y'all 0, negative 2, 0 on the x-axis, and then go down to negative 2 on the y-axis. And then my second point, 2, negative 3, go right 2 on the x, and then go down 3. So 1, 2, 3. Oh, yeah, at that point, once you got the 2 points plotted, MathLab will come in and draw your line. Now, Also, I'll show you on the calculator. On the calculator, you still want to solve it for y, and you're going to put that in for the equation and to go to y1, okay? So I'm going to actually share the calculator real quick. All right, I'm going to go to y equals. So to make that fraction, I'm going to hit the green alpha button, y equals, and enter. So that was a -1 on top, arrow down, put your 2 in, arrow right, and put the x in. And then I had -2. All right, y'all. So if I want to see the table of values, I hit second graph over here to the top right. That'll pull up a table. So I pick 0, there's 0, -2. And then I pick 2, so there's 2, -3. So you could use them points. You could use like -2, -1. Any of them points that you think is easy to graph, grab 2 of them and then go graph it. All right, so let's hit graph to see the graph. And y'all, if you notice, looks the same as we drew on our paper wall go. All right, so number 1, graph a straight line. So let's see what number 2's got for us. And number 2's another graph. We're going to graph y equals x cubed minus 1. So this is already solved for y, so you can go put that in the calculator just like it looks and see what kind of graph you're going to get and find on this one, it's a cubic. It's going to be the 4-point cubic tool. So it's the squiggly line on the cubes, and it needs 4 points. All right, y'all, so I'm going to set up my table. All right, so I need 4 points. So I'm going to do, let's say, I'll do -2, -1, 0, and 1. The only other number I would pick for this kind of cube would be a +2. Okay? But those are the only 5 numbers I would use on that because them cubes, exponents make them numbers really big, okay? So we need to put 4 of these numbers in there and see what those y values are. So I'm going to start with -2. -2 times -2 times -2 is a -8 minus 1, which gives me a -9. Then I'm going to put a -1 in. So -1 cubed minus 1. Well, y'all, -1 times -1 times -1 is -1 minus 1, which give us -2. All right, we'll put 0 in. Well, 0 to any exponent is 0. So I get 0 minus 1, which is -1. And then finally, let's put a +1 in. So 1 times 1 times 1 is 1. And I get 1 minus 0. And y'all, 1 minus 0 is 1. All right, so I got these 4 points. I'm going to graph this on this one. So let me get my points up here. So I got -2, -9. I got -1, -2. I got 0, -1. And then finally, 1, 1. All right, so remember in MathLab, choose that 4-point cubic tool first and then plot them points. So y'all, -2, -9 is down here. -1, -2 is right here. 0, -1, 0 on the X, down 1 on the Y. And then finally, right 1, up 1 for my last point. Once y'all draw the last point, MathLab will come in here and draw that graph up through them points and up. Okay, y'all, so let me highlight that. So MathLab will come in. Your graph is going to look really, really similar to mine. Okay, y'all? All righty. You can do that one on the calculator. So let me share that screen. So go to y equals, and we'll clear everything out. All right, so my problem had x cubed minus 1. So x, I'm going to arrow up for my exponent 3, arrow right and come back down and do -1. So if I want to see the table, I'm going to hit second graph. And there's your numbers. So see if you pick a 3, that's a pretty big y value to try to plot. So I would probably keep my x's in between that -2 and +2 on those x's. All right, didn't see the graph? Hit graph. And there you go. Little squiggly line going uphill, left to right. All right, y'all, let's see what number 3 has. So number 3 is not a graph, but we do have more graphing coming up in a little bit. But number 3, they're giving you this formula. F of C equals 9/5 C plus 32. So the Fahrenheit formula, if I know the Celsius temperature. So they want to know what Fahrenheit temperature is equivalent to 25 degrees Celsius. So basically, I'm finding F of 25, since that's what I'm putting in for my Celsius. All right, y'all. So put 25 in for C, and then we're going to work that right side. So you got 9/5 times C, which is 25, plus 32. So y'all on the calculator, you can punch it in right like we got it. Use the fraction notation and then multiply by 25, add 32. Now by hand, this will sort of cancel like the fractions did a while ago. So y'all, let's see if we get 77 there. So I'm going to cancel that, making that a 5. 9 times 5 is 45, plus 32. Oh, look at that. You got that right, because 45 and 32 give me 77. So that'll be 77 degrees Fahrenheit. And that one's multiple choice on that one. So you'll find A, B, C, D should have your number you get, okay? All right, you're going to determine if a function. So they're giving me a domain and a range. Now for my domain, they're giving me 22, 8, and 9. For my range, y'all, they're giving me 15 and 21. So the 22 points to the 15, the 8 points to the 21, and the 9 points to the 15. So I'm going to let y'all answer that and tell me if this little correspondence here, is it a function or not? All right, this is definitely a function. Good job. Because y'all remember, we focused on the domain. To be a function, every one of my domains can only point to one range value. So 22 only points to 15, 8 only points to 21, 9 only points to 15. We didn't say different domains couldn't share a range. Our only rule is that the domains can only have one value each. All right, y'all. So looks like we got some more graphing coming up. All right, so this would be number 5. On 5, we're going to graph f of x equals negative 4x plus 2. Now, this one, they already are going to give you the values to use. And then the difference in this problem than earlier, we're using function notation instead of y. But remember, f of x and y are basically the same thing, okay? So the numbers they're giving me are negative 2, 0, and 2. I got to find the 3 f of x values corresponding to those x's and then graph it. Now, this is a straight line. So in MATLAB, we're going to use the 2-point line tool. And we only got to plot 2 of these 3 points, okay? So you just pick the 2 that you find easiest and plot those. All righty, so I'm going to find all 3 of my values. So first will be f of negative 2. So I'm going to put a negative 2 in for x. I get negative 4 times negative 2 plus 2. All right, y'all, negative times negative makes that a positive 8. 8 plus 2 will give me 10. All right, let's find f of 0 next. That'll equal negative 4 times 0 plus 2. Well, y'all, negative 4 times 0, that's going to give me 0 plus 2, which is 2. And then finally, f of 2. That'll equal negative 4 times 2 plus 2. All right, now I got a negative times positive. That'll make that a negative 8 plus 2, which will give us a negative 6. All righty, so I'm going to plot these 2 points here. So I'm just going to go out about 6 on this. All righty, so yeah, these 2 points are easier for me, so I'm just going to plot them. 0, 2, 0 on the x, up 2 on the y. And then I'll do the 2, negative 6. So right 2 and down 6. And y'all, at that point, Once you plot that second point, MATLAB will come in and draw your line. All right, so that one can be done on MATLAB too. Just go to Y1 and put in that equation, same as that very first line I did, okay? All right, y'all. Another graph. So I think we got about two more graphs. So we're going to graph f of x equals -6 plus absolute value of x. Now this one, they're going to give you 5 numbers. They're giving me -2, -1, 0, 1, and 2. I think every one I've done has the same 5 numbers you got to find on this one, okay? Now, absolute value. It's going to be the V-shaped absolute value tool. And you got to plot that vertex first. And y'all, the vertex is going to be the middle point. So whatever your middle point is, when we get done, that has to be the very first point you plot in MATLAB, okay? All right, y'all, so let me find these values. F of -2 equals -6 plus absolute value of -2. So y'all figure out what that absolute value of -2 is. What is the absolute value of a -2? All right, one of y'all chat that or come unmuted. All right, Caleb, you got that. That's a 2. So that's going to be -6 plus 2. So y'all, whatever's inside them bars, when you take that absolute value, it's going to be positive every time, okay? All right, -6 and 2, -4. All right, let's put a -1 in. So -6 plus absolute value -1. We all bring down to -6. Absolute value -1 will be a +1. -6 and 1, -5. All right, put the 0 in. F of 0 is -6 plus absolute value 0. Well, y'all, that's -6. Absolute value 0 is 0. And -6 and 0 give you -6. So there's the first point I'm going to plot when I get into MATLAB, okay? All right, let me put a 1 in. F of 1 equals -6 plus absolute value of 1. All right, y'all bring down to -6. Absolute value of 1 is 1. And -6 and 1, give me -5. So see, -1 and 1 both gave you the same answer on these absolute values because the absolute value of a negative number is the same as its opposite, okay? All right, y'all, finally, f of 2. That's going to equal -6 plus absolute value of 2. So bring down to -6. Absolute value of 2 is 2. And -6 and 2 give us -4. All right, so when I plot this, I'm going to do 0, -6, and then I'll probably do my second point. I'm going to do 1, -5. So you got to plot that middle point first, and then you can choose any of those other 4 points. Okay? All right, y'all, so let me get this graph going. Now, like I said, in MATLAB, choose the 2-point absolute value tool. So y'all, I said I'm going to do 0, -6. So that'll be 0 down 6. So there's my first point. And then I said I'd do 1, -5. So write 1, down 5. So there's my second point. So then, y'all, MathLab is going to come in and draw a V-shaped graph for us. Okay, so MathLab, I'll highlight that again so y'all can see it good. Okay, so not bad. It's just coming up with them points. So how about that one on the calculator? So let's go to that calculator. I'll do this one because absolute value is tricky to find. So I'm going to clear everything off. So we're in y equals, I had -6. So -6 plus absolute value of x. To get absolute value, hit math button on the left side. Highlight one right to NUM is highlighted for number. And number 1 is highlighted ABS. Hit enter because that's absolute value. It'll put up the brackets, put your X in it, and then you can arrow out if you want. All right, so once again, I'll show you the table. Second graph. So there's the numbers they gave us, -2, -1, 0, 1, 2. And there's all the Y values we got. Now remember, let's hit graph and look at our graph. And y'all, there it is. Comes down in a V. Looks like it's touching at -6 like we said a while ago. Okay? All righty, one more graph, and then we'll be able to move on to other things. All righty, y'all. So this one is number 7. So we're going to graph. Now this one is very tricky. F of x equals -x² minus 3. This one is also giving us our 5 numbers. And y'all is doing the same 5, -2, -1, 0, 1, and 2. All right, x² graphs. You're going to use the 3-point x² tool, or they might call it the 3-point quadratic tool. But anytime you got an x² like that, you're using that U-shaped parabola tool. Now it's got 3 points, and on this one, it's not picky like the absolute value. On this one, I can plot any 3 of these points that I want to, and it'll give me the right graph. Okay? So, I'm going to find f of -2. Now, y'all be careful on this. So, watch what I'm doing. First of all, I'm going to bring that negative down. That negative is in the formula here, or the function. Then I got x². So now I'm going to put in this -2. I'm going to square that, and then -3. All right, this exponent only affects this -2 here. So this first negative, I'm going to bring down. Then I'm going to square that -2. So -2 times -2 makes that a +4. So that negative in front is going to keep whatever number you square here. That negative in front is going to keep it negative. And then bring down that -3. And y'all, -4 minus 3, -7. All right, f of -1 is going to be that negative times -1 squared minus 3. So this is one of the places when you can't make them two negatives into a positive, because that exponent means there's really 2 negatives here plus that negative. So you really got 3 negatives there, okay? So bring down that negative, square that -1, which gives you a +1, and then -3. So -1 minus 3, -4. All right, y'all, f of 0 is a negative times 0 squared minus 3. All right, 0 squared is 0 times that negative is 0. So you're going to get 0 minus 3, which is -3. All right, f of 1 is next. So that negative is still in the formula. And then put your 1 in, square that, -3. So since this negative is not in parentheses, you do not square that negative. So bring that negative down. This exponent only affects the 1. And 1 times 1 is 1. And then bring down -3. So y'all look, if you got a negative in front of the x squared, I don't care if you're putting in a negative number, it'll stay negative, or a positive number, it'll stay negative. And then y'all, that gives us -4. So look, the -1 and the +1 both gave me -4. So I'm going to get the same thing for 2 that I got for -2. So that'll be a negative times 2 squared minus 3. Once again, bring that negative down. The exponent only affects the 2. 2 times 2 is 4. Bring down that -3. And y'all look at that. -4 minus 3 give us a -7. So when I graph that one on here, I'm going to use the 3-point graph tool in MathLab. And y'all, I'm going to plot 3 of them points. So I'm going to probably plot these 3 positive numbers. But you can do any 3 of these, and the order don't matter. So I'm going to do 0, -3, which is right there. 1, -4, which is right there. And then 2, -7, which is right there. So by hand, draw that, and then mirror it on the other side. Okay, MathLab will all automatically mirror it. But y'all remember, since you're using the 3-point quadratic tool, if you only plot 3 points on one side, you got to mirror that on that other, okay? All right, y'all, so, and I'll highlight that again. All right, y'all, well, you'll be happy. That's the last of the graphing. So now it's going to get into functions. And let's see. On this next one, y'all are going to determine if the graph is a function. All right, so my graph looks like, see, on my graph they gave me looks like a sideways parabola. So let me ask y'all if this is a function. Oh, good job, y'all. That is definitely no. Good job. And the quickest way to tell is to draw a vertical line on that. Y'all, if you draw a vertical line through that graph and it hits more than once, so that graph hits twice, if it hits more than once, it's definitely no on that one. Okay? And y'all, it didn't matter where I drew them vertical lines, it's hitting it twice almost everywhere. So that means this X got 2 choices, But remember a while ago, we said x's cannot have but one choice, okay? Alrighty, let's see. Number 9. Find the domain. And y'all, guess what? The only thing I'm ever worried about on a domain is whether it's got a fraction or not. And y'all, guess what? I'm giving you a fraction. So 6 over 9 minus 7x. And no, and really, the only thing I'm worried about on a domain is that this denominator cannot equal 0. So usually what we do to find out what numbers make it equal 0, we're going to set it equal to 0 and solve for x. Any answers we get, we're going to kick them out of our domain, okay? All right, y'all, so let's go. We're going to what? Subtract 9. Get the x's on the left side by themselves. So that gives me a negative 7x. 0 negative 9 is negative 9. All right, now we'll divide both sides by negative 7. So negative divided by negative makes that a positive x. Negative divided by negative makes that a positive 9/7. So since we got 9/7 when we solve that denominator, that means we got to kick that 9/7 out of our domain. So our domain will be x such that x is a real number and x cannot equal 9 over 7. Now you got to pick the one with the not equals. They might do a greater than or a less than there, but you got to pick the one with the not equals, okay? All right, now we're getting into operations on functions. So we're going to let f of x equal negative 15x plus 15. G of x is going to equal x squared plus 2. They want me to find f of negative 2 plus g of negative 2. So they want me to add two functions and put a number in for these x's. If they give you a number here, you got to come up with a single number for your answer, okay? All right, y'all, here we go. F of negative 2 plus g of negative 2 will equal my f, which is negative 15, times x, which is negative 2, plus 15. All right, close in parentheses, plus, open the next ones. That's x squared, so I'm putting a negative 2 in for the x squared. So that's going to be negative 2 squared plus 2. All righty. I'm going to work inside the first parentheses and work inside the second parentheses. So order of operations, I got to multiply first. So a negative times negative makes that a positive 30 plus your 15. Over here, you're going to do the exponent. Any number you square better come out positive. So negative 2 times negative 2 makes that a 4 plus my 2. All right, all we got to do is add now. Finish out this one. 30 and 15 will give me 45. Since that's the last operation I could do, I can drop parentheses. And then 4 plus 2 gave me 6. I can drop them parentheses. All right, now I just add these two and be done. So 45 and 6 give me a final answer of 51. All right, also, that's the trick on these. If you put them numbers in for them x's, okay? So the next one's going to be the same thing. They're giving me numbers for my replacements. So f of x is negative 11x plus 12. G of x is going to equal x squared plus 18. We're going to find f of a negative 3 divided by g of a negative 3. I have noticed on these that they're giving you the same number for both functions, okay? All right, so I'm going to make this look like a fraction since it's division. So f of negative 3 divided by my g of negative 3. All right, so f is negative 11 times x, which is negative 3, plus 12. On bottom, g is negative 3 squared plus 18. All right, so I'm going to multiply on top first. Negative times negative makes that a positive 33 plus my 12. On the bottom, negative 3 squared is a positive 9 plus 18. All right, y'all, so let's see what I get. 33 and 12 give me 45 on top. 9 and 18 give me 27 on the bottom. So now I got to try to reduce this. And let's see. I know 3 will go into both of those. Oh, y'all, I can also divide both of these by 9. And I think 9 is the largest number they got in common. So I'm going to divide top and bottom by 9. So that this reduces to a 5 over 3. Now, you can reduce fractions on the calculator, right? So let me show you this problem on the calculator. So I'm going to get off the y equals stuff and clear. So I'm going to hit alpha y equals to make this look like a fraction and enter. On top I had negative 11 times negative, times negative 3 plus 12. On bottom, I had that negative 3 squared. Make sure you put negative 3 in parentheses. And then that one was plus 2. Whoops, that was plus 18, my bad. 1, 8. All right, I was looking at another problem there. But y'all, what's nice, if you put it in as a fraction like that, when I hit enter, I'll get my final answer, 5/3, okay? So either way on that one. All right, y'all, so that puts me on number 12 now. So for this one, f of x is going to equal negative 5x plus 2. G of x is going to equal x squared plus 2. I'm going to find f plus g of x. All right, so now we're adding two functions. They're not giving me any replacement values for the x. So you better not come up with a single number for this answer because there's not nothing you can do to get rid of the x squareds and the x's, okay? So here we go. F plus g of x equals my f plus my g. F is negative 5x plus 2. G is x squared plus 2. Now, since we're adding, we can drop the parentheses and bring everything out. So that'd be what, a plus x squared plus 2. And y'all, at this point, I'm going to put it in descending order and add those like terms together. So the first thing I got is the x squared. It don't have anything else to combine with, so bring down that x squared. Then I would bring down the x's. Well, they don't have any other like terms, so bring down that negative 5x. But y'all, the like terms, I got a 2 plus 2, which will give us positive 4. Cannot go any further, so we're going to stop there. All right, let's see this one. Another one. F of x is going to equal, oh, y'all, negative 4x plus 4. G of x is going to equal x squared minus 5. This time we're going to find g minus f of x. Once again, they're not giving me a number, so we're going to end up with a lot of x's, okay? All right, so y'all, here we go. G minus f of x will be my g minus my f. So g is first on this, so bring out that x squared minus 5. And then for your f, put in negative 4x plus 4. Now, the difference between subtracting and adding is you gotta distribute that negative times both of these, okay? So you drop the first parentheses, x squared minus 5. But y'all, a negative times a negative makes that a positive 4x. Negative times a positive makes that a negative 4. All right, so I'm going to put it in order, and the only like terms I got are my numbers again. So y'all, I'm going to bring down the x squared, bring down the positive 4x, and then negative 5 minus 4 gives me a negative 9. So 10 and 11, they gave you numbers, so you ended up with a single number. 12 and 13, they didn't give you numbers, so you still had all your variables left when you were done, okay? All right, so for this one, for F and G, determine the domain of the sum, difference, and product. So it's almost like a three-part question, okay? You'll do the sum, then you'll figure out the difference, then you'll figure out the product. Now the functions are f of x equals 1 over x minus 10, g of x equals 6x cubed. So the sum, that'll be this function plus that function. So f plus g of x equals the f, 1 over x minus 10, plus the g, 6x cubed. So y'all, this will be on y'all, but what I want to know is, should I exclude any numbers from my domain if I'm going to add them two functions? All right, y'all. So on a domain, remember back when we did, I forget what number it was, we did a domain problem with a fraction. When you're dealing with a domain, all you're worried about is fractions that got a variable in that denominator. Okay? So what number is the only number I got to exclude from this domain? Because remember, I cannot have a fraction that turns into something that is undefined. So y'all, that means the only number this x cannot be is a positive 10. There you go. Right? So that domain will be this x such that x is a real number and x cannot equal 10. All right, y'all. So the difference would be f minus g of x. That'll be 1 over x minus 10 minus 6x cubed. Or is it not the same situation? You still got the only fraction here with the variable in the bottom. So that x still cannot equal 10. So the domain is going to be exactly the same. X such that x is a real number and x cannot equal a positive 10. Now, y'all, I'll tell you on MATLAB, you got to put this whole thing in there. You got to put the x not equal to 10. If you just put a 10, it'll mark it wrong. If you just put not equal 10, it'll mark it wrong. It's got to have the whole thing in there, okay? All right, f times g of x will equal this f, x 1 over x minus 10, times g, 6x cubed. But y'all look, it's the same fraction that we're worried about. So for the third time, x cannot equal 10. These three will always have the same domain, which means this one will be x is a real number and x cannot equal a positive 10. Those three have the same domain every time, y'all, okay? All right, so I'm going to let y'all catch up a second. We got some big boys coming up. There's only 20 on the test, but I got some big ones coming up. So y'all, number 15. 15 is going to be a system of equations. So number 15 says solve. X plus y plus z equals -1. 2x plus 5y plus 2z equals -8. X plus 6y minus 3z equals -15. All right, so y'all are pretty much working this by hand, or y'all mostly doing it by calculator. And now this is a system of three variables. So we're going to start eliminating. So y'all on mine, I'm going to eliminate that x. Now remember, I got to add 2 rows at a time, but all 3 rows have to be used. So first, I'm going to add the first equation and the last equation. So I'm going to add first equation and the last equation. All right, so the first one, x plus y plus z equaled -1. My last equation was -x plus 6y minus 3z equaled -15. Adding them together, them x's cancel. So 1y and 6y gave me 7y. 1z minus 3z gave me -2z. -1 minus 15 gave me -16. So that's the first equation I needed when I get a two variable system. Now, no matter what, we got to use the middle row and add to one of the others. But y'all, I'm going to have to change one of the others if I'm going to cancel them x's. So since that one's got a positive 2x, I'm going to take this third equation and multiply everybody by 2. So I'm going to change the third equation and I'm going to add it to the first equation. So, I mean the second equation. So I'm going to add the second equation and the last equation after changing the last equation. Okay? So this second equation stays the same. 2x plus 5y plus 2z equals -8. Multiplying this second equation by 2 gives me a -2x, positive 12y, -6z, and then 2 times -15 is a -30. But y'all doing that, my x's cancel again. So what's left will be 5 and 12, which is 17y. 2 minus 6 is a -4z. -8 minus 30 is a -38. We now have two equations with y and z in them. So we're going to put them together. Now we got to eliminate one of these two variables. So y'all, I'm going to eliminate the z this time. And the way I'm going to eliminate the z, that one's -4. So I'm going to change that -2 into a +4. So to change that -2 into a +4, I'm multiplying this whole row by -2. So I'm going to change first equation, then add to the second. All right, y'all, so bring that down. So changing the first equation, -2 times 7 gave me -14y. -2 times -2 gave me a +4z. -2 times -16 gives me a +32. All right, we didn't change the second equation. 17y minus 4z equal -38. All right, y'all look at that. The z's cancel. So -14 and 17 will give you 3y. 32 minus 38 gives you -6. I can now solve this for the y by dividing both sides by 3. So y'all, that gives me y equals -2. So since I know what y is, I can start back substituting. Since I know y is negative 2, I'm going to plug it into one of these two variables, these two equations. Because if I know the y, I can solve that for the z. So I'm just going to back substitute into this one. It had smaller numbers. So I got 7 times y, which is negative 2, minus 2z is going to equal negative 16. All right, first thing I would do is multiply. That gives you negative 14 minus 2z is negative 16. All right, now we're solving for z, so let's add 14. Oh, that cancels. I got this negative 2z. Negative 16 plus 14 is negative 2. All right, so now divide by negative 2 and see what z equals. And y'all, z, negative divided by negative makes everything positive. So z is now a positive 1. And finally, I can back substitute. So I'll pull it down a second. I'm going to back substitute into one of the three original equations because I know what y and z are. So I'm going to get the x, okay? So I'm going to plug in for y, plug in for z, then solve for x. So we don't know x. I know y was negative 2. Z was a positive 1. All that's going to equal negative 1. Oh, you also want to add like terms. Negative 2 plus 1 gives me a negative 1 equal to my negative 1. And y'all add 1 to both sides. And that was going to give me x equals 0. So if you add 0 and 1, you get 1. Added to negative 2 gives me negative 1. And y'all, that's what that said those three should equal when I added them. Now, MathLab, they already got the parentheses. All you're doing is putting in your numbers in alphabetical order. X, Y, Z. Into order, okay? And then my Z. But y'all, like I said, you do not have to put the parentheses. MathLab already has those parentheses, okay? Righty. Are any of y'all doing that on the calculator?
No.
Say again.
No,
So,
sir.
so no. Okay, so y'all ain't using the calculator. I won't even worry about it on there then. So let's go to the next one. That was what, number 15? All right, number 16 is next. Y'all, if you do want to use a calculator, I got videos in MathLab um, under that 30.5, section 3.5, where you can use the calculator on it, okay? All right, so this one wants you to translate this statement. So you're going to translate it. It says the first number is 50 more than the sum of the other two numbers. So they just want me to translate that, and I'll use X, Y, and Z. So I don't know the first number, so I'm going to let that be X. Now you got is. Is your equals. And then it's 50 more than the sum of the other two. So the other two numbers, I don't know what they are. So I'm going to make that Y plus z. There's the sum of my other two numbers. And then 50 more meant plus 50. Now the trick on this one is to get everything on one side equal to that 50. So if you're going to move the y over, you're going to subtract y from both sides. If you're going to move the z over, you're going to subtract z from both sides. So you're going to subtract y from both sides. So I'll just do it in steps. So that'll give me x minus y equals z plus 50. Now move the z over by subtracting it. So you get x minus y minus z equal to your 50. So this one will have like three choices. You want the one where you got the x minus y minus z equal to whatever your number is, okay? Mine was 50 more. Y'all's will be something different there, but it's still going to be the same setup as mine, okay? Oh, y'all, 17, here we go. In triangle ABC, angle B, so the measure of angle B, so angle B is 2 degrees more than 3 times angle A. All right, then it says angle C is 43 degrees more than angle A. Then they say find the measure of each angle. All righty, so y'all going to have to know my third equation. I'll get the first two, and then y'all got to know the third one. All right, so the first one, B is 2 more than 3 times A. That's going to be B equals 3 times A plus 2. Now, in a second, I'm going to move that A to the other side and make it negative, remember? All right, my second equation, C is equals 43 more than A. So that'll be A plus 43. All righty, I need the last equation y'all would use. So let's see if y'all remember. What was my third equation? All right, so A plus B plus C equals 180. All right, so I'm going to let that be my first equation because it's got everything on the right side. So I'm going to make a little system here to start eliminating. All right, on the first equation, you move the A over here by making it negative. So that equation will give you negative 3A plus the B. That one's going to equal 2. And on this middle equation, move the A over, making it negative. So that'll give you negative A plus C equals 43. And so at that point, I got to figure out what variable to eliminate. So y'all, the one I'm going to eliminate is either the B or the C. So I think I'm going to what do you call it? I'm going to eliminate the b. Okay, so if I'm going to eliminate b, I'm going to multiply this second row here by a -1. Because that b is positive, I have to make this one negative, okay? So doing that, I didn't change the first row. So that'll be a plus b plus c equals 180. I'm going to multiply this equation by -1. So negative times negative makes that a positive 3a. Negative times positive makes that a negative b. And then a negative times positive makes that a -2. All right, so see what happens. 1 and 3 give me 4a. Yeah, this will be on the quiz. Everything I'm doing, these 20 questions I'm doing today will be the same 20 on y'all's quiz and your test, okay? All right, y'all, the B's canceled. That brings down to C. 180 minus 2 is 178. But y'all look, A and C, remember, I got to use all three of these equations. I done used the first two. This one already has a B eliminated, so it will become my second equation. So I bring over the 4a plus c equals 178. This last equation automatically comes over, so -a plus c equals 43. So y'all look what's happening. 4 minus 1 leaves me 3a. Oh, hang on. We got to decide what we're going to eliminate, okay? So you can eliminate the A or the C here. So for this one, I think I'm going to eliminate the A. And if I'm going to multiply the A, that's a positive 4A. We're going to multiply this one to make a negative 4A. So I'm going to eliminate A. So y'all, the first equation stays the same. 4A plus C equals 178. Multiplying this one by 4, you get a negative 4A. 4 times C is a 4C. 4 times 43, that's 160 and 12. So I'm getting what, 172? All right, let's see what happens. The A's cancel. 1 and 4 give me 5C. 178 and 172 gives me 350. But y'all look at that. I can now solve for angle C by dividing both sides by 5. So that C equals 70 degrees. All right. Now, since I know C, I can get A really quick because I know C. Once I know A, I can plug in there and get B really quick. So let me get this A right here by plugging in for C, which was 70. All right, y'all, so I'm going to back substitute. So C was 70. That's going to equal A plus 43. So y'all, all we got to do is subtract 43 and we'll have A by itself. All righty, so 70 minus 43 gives me 27 equal to my A. So I know 70 for C, 27 for A. So now to back substitute and get B. And y'all to substitute for B, since I know A, I'm just going to use this equation. B equals 3 times A plus 2. So B equals 3 times 27 plus 2. All right, y'all, so let's see what we get here. 3 times 27 is 81 plus 2, which gives me a final angle of 83. So MathLab will have it where you got to put in each of your three angles. A was 27. B was 83. And then C was 70. All right, y'all, so let me show you a trick on this. These were the three equations where everything was on its side, on one side equal to the numbers. In MathLab, I'll show you how to do the matrix, but all I'm putting in are the numbers. So in the matrix, I'll put 1, 1, 1, 180. I'll do -3, 1 for the B. There's no C here, so that's 0, and then 2. The last row, I'll do -1, 0 for the missing B, 1 for the C, and 43. All right, so let me share the calculator. These will be the numbers I put in. All right, so let me clear this thing off. All right, so this stuff is in the matrix. Second, x -1, go to edit. Mine's already set up for a 3x4, so hit enter twice. I had 1, 1, 1, 180 goes there. Next row, I had -3, enter, 1, enter, 0, enter, 2, enter. My last row was -1, enter, 0, enter, 1, enter, and 43, enter. So you enter all those in. Now, quit the screen. Hit second mode. All right, next I'll get the RREF by hitting second, x -1, arrow over and highlight math, and then arrow down and get RREF, hit enter, and then hit second, x -1 to get that matrix by hitting enter. All right, remember the right side, the right column will be the answers from top to bottom in alphabetical order. And y'all, there you go. There's my 27, 83, and 70. So these aren't bad. You'll get those answers either way. All right. Oh, y'all, look here. Another system. The sum of three numbers is 55. Difference of the largest and smallest is 51. Then it says the sum of the two smaller numbers is 11. Find the numbers. So this is going to be another system of three equations. But you'll notice on this one again, it will have stuff that sort of cancels out, okay? Or that's missing one of the variables. So we don't know those numbers, but we got three numbers and they equal 55. So x plus y plus z equals 55. All right, the difference of the largest, which is my x, and the smallest, which is my z, so difference means subtraction. The difference of those is 51. And then the sum of my two smaller numbers, which would be y and z, so y plus my z, those equaled 11. All right, so give me a letter to eliminate, y'all. Any three of them letters we can solve this by. So let me think what y'all are thinking on this. What variable can we eliminate? All right, so we can do the z. I'm going to add the first two equations, get rid of z. Then I'll add the last two to get rid of the z. Okay, because that z will cancel out quick. So y'all, let's eliminate z. So we got to do this twice. So first I'm going to add the first two equations. X plus y plus z equals 55. X minus z equals 51. But y'all look, that gives me 2x plus a y. The z's canceled, and 55 and 51 give me 106. All right, so we're going to eliminate z again. But now we got to use the last equation for sure. So we might as well add these last two to get rid of this z. So you got x minus z equaled 51. This one was y plus z equaled 11. So y'all, I got an x. I got a y. Those z's canceled. 51 and 11 give me 62. All righty, so these two now become your new system. So 2x plus y was 106. X plus y was 62. All right, so what are y'all wanting to eliminate on these two variables? So all we got left is x's and y. What's next? So y'all want to do the y? All righty, so if I'm going to do the y, I'm going to have to multiply this row by -1. So that'll give me a negative y and they'll cancel. So don't change the first row. So I'm going to leave that one. 2x plus y equals 106. I want to multiply this row by -1. So I get a negative x minus y equals a negative 62. Oh, y'all did good because the y's cancel. And look at this. 2 minus 1 leaves you 1x. So once we subtract 62 from 106, we'll have x solved for all the way. So y'all, what is that? 106 minus 62. Somebody hit that on the calculator for us. All right, good job. 44. All righty, so I know x. I can put x right here, solve for that z. So I'm going to back substitute and put in x, which was 44, minus z equals 51. All right, y'all, here we go. Subtract 44 from both sides. That cancels. I got negative z equals 7. But z's got to end up positive. So let's divide both sides by -1. So that z now equals a -7. One of your three numbers is always negative on this problem, okay? All right, so to get the y, the very first variable we eliminated was the y, wasn't it? Where was we at? Oh, we have eliminated y right here. But it don't matter. I got a y right here plus z equals 11. I know what z is, -7. So I'm just going to plug that into that last equation. Y plus z, which is -7, has to equal 11. And there's just one move. Add 7. And I get y equals 18. So it's going to want the numbers in uh, largest to smallest. Well, that's going to go in the order I did them. X, Y, Z. That's my largest number, 44. My next number would be the Y, which was 18. And then my smallest number would be Z, which was -7. So remember, MathLab will ask for those to be in order from largest to smallest. Oh, yeah, I just got two left. 19 says graph the inequality, and they're giving me y greater than. So y greater than x minus 5. So y'all, the trick on that is come up with 2 points. So I would set up a little table real quick. All right, somebody give me 2 x values to put on this table. So I just need 2 x values because this one will be using the line tool. So give me 2 x values, 0 and 3. All right, 0 in for x. 0 minus 5 gives us a -5 for that y. And then let's put that 3 in for x. 3 minus 5 gives us a -2. All right, so those numbers are fairly small, so I'm going to go out 5. All right, I got to ask y'all this. I'm going to plot these 2 points. 0, -5 is down here at -5 on the y-axis. 3, -2 will be right 3, down 2. All right, I need to know though, am I needing to use a solid line or a dashed line? It's got to be dashed. So remember, in MathLab, you got to choose. You got to choose the dash line tool before you even plot those points in MathLab, okay? So choose the line tool, choose the dashed option, then plot your 2 points. At that point, MathLab's going to come in, draw a dashed line for you. So my only other question is, would I shade that above or would I shade that below? All right, y'all. So remember, you're looking at this greater than. So think about it. Are the y values greater going up or are they greater going down? So y'all are saying above? Because remember, if it's greater than, you're going to shade above that line. So you would come in and shade everything that's above that line, okay? Y'all remember, I showed y'all how to do that one on the calculator. So go to y equals, clear all this off. Put in x minus 5. arrow all the way left, hit enter. So I'm going to shade mine yellow like Math Lab. And then I'm shading above, so I'm going to arrow that till you got the triangle bigger on top. Then hit OK. Only thing the calculator won't do is a dashed line. You got to remember in MathLab to put that dashed line if you got it, okay? All right, y'all, let's hit graph. There's the graph we just did. And if you want points, second graph, there's your table of numbers to pick. All righty, I just got one left. Number 20. Number 20 is a system of equations. So we're going to graph the system of inequalities. So y'all, I got y greater than or equal to x plus 4, y less than or equal to 3 minus x. So this one, when you do it, you're going to choose A, B, C, or D for that one. And if you want to, you can put that one in Y1, make it shade above. Put this one in Y2, make it shade below. And you're looking for their intersection, okay? So I'm just going to do an X and Y table for both of these real quick so that I can plot the two lines and see where they intersect. All right, so I need two numbers for X here. I'm just going to use 0 and 1 for both of these. So 0 plus 4 gives me 4. 1 plus 4 gives me 5. So I got 0, 4, 1, 5. But y'all, if you do this number 20 enough times, you're going to notice a pattern for the answer. So let me play with this one. 0, 4, 0, up 4. 1, 5, right 1, up 5. Now, these will both be solid lines, and all the pictures have solid lines in MathLab. But on this first one, it's greater than, so this first one's going to shade all above this line. All right, let's do the second one. If I put a 0 in for x, 3 minus 0 is 3. If I put a 1 in for x, 3 minus 1 is 2. So that one I got 0 up 3. And then 1 right up 2. So that line's coming down like this. It's less than, so we're going to shade below this line. So all this is getting shaded. So y'all look at that. The double shaded section for me is all this right in here. This is where I got all my double shading from both of the graphs. So I need to choose the MathLab picture that would match that. And y'all, that would be A, where that left side was shaded. Every time I've done this problem, it's that same picture, okay? They move the picture around, but every time I done it the other day and today, it was that same picture A. Now, if they change them greater thans and less thans around, you might get a different picture. But I'm just saying, every time I done it, it was that picture right there. So we would have picked A for me on that one. All righty, y'all. So I'm going to stop that share. And then I'm going to stop this recording.